Welcome to the 2018 Stats and Mechanics Paper 3. In this iteration they came as one single paper. So I shall do both of them back to back in one video. Alright, starting with question number 1. This is the probability distribution. It tells us that this is a uniform distribution, therefore all of the outcomes will have equal probability. The outcomes run from 0 to 8. So that's a total of 9 possible outcomes, and with a uniform distribution, that means that each probability is going to be 1/9. For B, we need it to be less than 50%, so of the 8 possible outcomes, we need it to be less than 4. So we're looking at 0, 1, 2, and 3. So the probability C less than 4 will be 1/9 plus 1/9 plus 1/9 plus 1/9, which adds together to make 4/9. For C, the actual probability comes out as 0.315. That's much less than Helen's model, and therefore the model is not going to be suitable. The probability is less than the 4/9 that Helen's model predicted. I suppose that's not surprising. Helen's using a uniform model. A uniform model is clearly not going to do a good job of representing cloud cover. Cloud cover is not going to be, when you just look outside, cloud cover is never going to be uniformly distributed. And so my advice to Helen is to not use a uniform distribution, but a better one. All right, question 2. We have Tessa and her shop in the seaside town. So the null hypothesis, H0, is that rho is equal to 0, and the alternative hypothesis is the one-tailed test rho is less than 0. The critical value we have to look up in the data book, and that will come out as negative 0.6215. If you find the right table, the right row, the right column. Now it tells us that the product moment correlation coefficient is negative 0.915. That is less than the critical value. Essentially, there's more of a correlation here than we need to change our minds, and we can therefore reject the null hypothesis. Except the alternative hypothesis, yes, there is evidence of a negative correlation. Okay, for B, possible reasons for this. I think if the sun is shining at a seaside town, people are more likely to head for the beach. Whereas if the rain comes, then they're probably going to head indoors to somewhere like a shop, and therefore more likely to do some shopping. That's my suggestion as to why that might be the case. Now, because R is close to 1 for C, a linear regression, close to -1, sorry, linear regression model is definitely going to be suitable here. And then for D, we're likely to have the sales dependent upon the temperature. The temperature is not going to be dependent upon the sales, so T for D. And then for E, that value, the -171, is telling us that for each degree the temperature goes up, her sales go down by 171 pounds. So that tells us the connection between temperature and sales. Every 1 degree higher, 171 pounds less is earned. All right, question number 3. This is the binomial distribution question. So 10 trials, 0.1 probability of success. Conditions for a binomial, there are always quite a few of them. Each throw of the dart is an independent event. The probability of hitting the target is constant. Those are the two straightforward ones. Fixed number of trials would have been fine as well. Then for B, using Peter's model, probability of H being greater than or equal to 4, you plug that into your calculator, it comes out to 0.0128. For C, probability that F equals 5, well, we need four misses in a row and then a success, so probability of a miss 0.9, so it'd be 0.9 to the power of 4, and then the success on the fifth throw, so times the 0.1, that comes out as 0.06561. For D, we need to plug in all the possible values of n into the formula, and if we sum them all, it will sum to 1. To save a bit of space, each one of those is going to have a 0.01 at the front, so I'm just going to times that by 10. Rather than write add 0.01 plus and then some lot of A. So 0.01 times 10, that covers all 10 throws, and then we're going to get an A, a 2A, 3A, 4A, 5A. Of course, the first one, when n is 1, there is no A. So we go all the way up to when n is 10, which gives us 9A, and that's going to sum to 1. So 0.1 plus 45A, after collecting like terms, is equal to 1. Subtract 0.1 divided by 45A is 0.02. For E, probability of F equaling 5, so we just plug 5 into the formula, so 0.01 plus 5 minus 1 lots of 0.02. .01 plus 4 times 0.02, that's 0.09. And then for F, the difference between the two models, well, Peter's model has a consistent probability of success, whereas Thomas's model assumes that the probability of success increases as you go along. You can decide for yourself which one is more realistic. But that's the difference between the two. For question 4, I can only apologise. I'm writing the answers next to each questions rather than the lined parts. It looks horrendous, I know. Okay, the sampling is convenient sampling. You just got to learn your sampling types. For B, it's quota sampling. C is a census. There's not much more to say about those. The interquartile range, read off your upper quartile, 58, lower quartile, 26. The difference is 32. Then to calculate the mean and the standard deviation, well, the mean is the sum of x divided by n. So that's 4133 over 95, which comes out as 43.5. Then the standard deviation, use the formula. It's going to be the sum of x squared divided by n, subtract the mean squared, and then all square rooted. And again, I apologise, that looks horrendous. I should have double screened that one. Don't worry. It gets better as it goes on. Anyway, plugging that into the calculator, the standard deviation comes out as 15.4. For F, our recommendation, well, there are two outliers, and the problem with outliers is that they will skew a mean, and they will skew a standard deviation as well. So in this instance, I'd suggest using the median, which is not affected by the outliers, and the interquartile range, not the mean and standard deviation. Then for G, The median and the upper quartile will change if you ever think about where they go in the data set. And the median and the upper quartile will be lower than they were before. And that's the end of that question. Let's get it off the screen as quickly as we can. All right, back to sensible structure of answers. Okay, for 5a, the probability that L is greater than 16, you just plug that into your calculator, it will tell you that it is 0.691. And then for B, we're looking at the probability that the length of the battery life is greater than 20, given it's greater than 16. So that's going to be the probability that the length is greater than 20 divided by the length being greater than 16. Obviously, if the length is greater than 20, it will be greater than 16. So in terms of the intersection in the conditional probability formula, just P of L is greater than 20 is sufficient here. So we've got 0.309, it's probability that L is greater than 20, divided by our answer in A, 0.691. Try to use unrounded answers if you can. Anyway, it comes out to 0.446. Now we need all 4 batteries to last for this to work, so we need the first one and the second one and the third one and the fourth one, so we're going to have to raise that to the power of 4, so 0.0396, that's a 3.96% chance. Not good odds if you're going into an exam, I'd suggest. Then for C, well, we need 2 batteries that are new to have a length greater than 4 hours. And as well as the other 2 being greater than 20, given that they're greater than 16. So I'm going to square both of those because they apply to 2 batteries each. Probability of L is greater than 4 is 0.99976. Highly likely that it's going to last more than 4 hours. And then we already have the calculation for probability of L being greater than 20, given it's greater than 16, so 0.4461, and that's squared. Times them together, we got 0.199, so 19.9% chance, still not good odds. The hypothesis test, so the mean is 18, the alternative hypothesis is that the mean is greater than 18. So we're looking at the distribution of sample means here, so we'll have a normal distribution with a mean of 18 and the standard deviation of 4 over root 20. And we want to calculate the probability that our battery length, the means, the distribution of sample means, is greater than 19.2 with those conditions. Plug that into your calculator, you get 0.08986, and what's important is that that is greater than 0.05, which is the significance level, and therefore we cannot reject the null hypothesis, or we do not reject the null hypothesis. We accept H0. There is insufficient evidence to support Alice's belief there. Sorry, Alice. Probably should just put 4 brand new batteries in your calculator before an exam. I think whoever wrote this question is talking from real life experience there. Right, on to the mechanics. So we're looking at S being equal to, well, we want the displacement, so to get the displacement we are going to integrate our velocity, so integrate, add 1 to the power, divide by the new power, so 2t to the half lots of I minus 2t squared lots of j. If you turn that into column vectors, it's absolutely fine. Then the displacement at the 2 points when t equals 1 and 4, we can plug in 1 and 4 into our equation. So when t is 1, our displacement is 2i minus 2j. When t is 4, our displacement is 4i minus 32j. So to find the length, we can do Pythagoras. The difference between the i's is, well, 2i to 4i is 2. The difference between the j's from negative 2 to negative 32 is 30. So the distance will be the square root of, and then the 2 squared plus 30 squared, which is the square root of 904. It does want the exact distance, so I'm going to leave my answer as root 904. Question 7. So we've got some friction. We've got a pulling force, we've got a normal reaction force. We've got a weight. Friction's going to be acting against the direction of motion. The weight is 20g. It's the mass times g. Worth noting, a little triangle here tells us that tan of alpha is 3/4. So we're dealing with a 3, 4, 5 triangle that just helps us with some of our calculations. All right, to find the normal reaction force, we'll resolve in a vertical direction. Forces acting downwards will be equal to the forcing acting upwards. 20g equals r plus 40 sine alpha. Sine alpha we know is going to be 3/5. So 40 times 3/5 is 24. Subtract that from 20g. 20g is 196. And we get a normal reaction force of 172. We can times the normal reaction force by the coefficient of friction. So 172 times 0.14. And we can resolve horizontally and put in our values into F equals ma. So the forces acting to the right, 40 cos alpha, subtract the forces acting to the left, that's 0.14 times 172 is equal to the mass times the acceleration. Divide both sides by 20, we know cos alpha is 4/5. We get an acceleration of 0.396. By pushing into the ground in the diagram for part B, you're going to increase the normal reaction force, and that's going to increase the friction acting on the block, and a higher level of friction is going to resist the motion, so the resultant force will be lower, which means that the acceleration will be lower. You can test that using an eraser on a table. Try pushing it into the table and moving it. It's just always harder to do. Alright, question number 8. So we're looking at Suvat equations here. It's often helpful to write out what you know. I'm going to do this one using column vectors just to mix it up. If you've stuck with your i's and j's, that's absolutely fine. Here for part A, we have t is 2, u is 2 minus 3. We're trying to find the acceleration, and the displacement s is 7, negative 10. So s equals ut plus a half at squared. S is 7, negative 10. U is 2, negative 3. T is 2. Plus a half, and then a, and then t is 2, so it's times 2 squared. So if we times 2 minus 3 by 2, bring that onto the left hand side, and a half times a times 2 squared is 2a, and so our value for a is 1.5, negative 2. We want the magnitude of that, so we'll stick it into Pythagoras. 1.5 squared plus negative 2 squared, all square rooted, comes out to 2.5 meters per second squared. For B, we've got V equals 2, negative 3 plus 1.5, negative 2 times 2. Gives us a V of 5, negative 7. Then, if we take that as our new value of u, We've got A to be 4 and 8.8, and we're working out T. Well, we want to find the time at which sort of the I components and the J components are the same, or the X and the Y if you're working with column vectors, and so we can equate them. So 5 plus 4t is going to be equal to -7 plus 8.8t. We're going to find the value of t of which this particle is heading exactly northeast. The X and the Y parts will be the same. That's using the formula v equals u plus at and equating them. And you solve the equation, t equals 2.5 seconds. Alright, question 9. You'll be relieved to know that I've split this one, so no more horrendous writing over the questions. For part A, we're going to take moments about A. Clockwise moments about A to start with. Well, we've got the mass of the plank, so we take the centre of mass in the middle, times it by its weight, mg. So it's going to give us mga, plus the weight of the block, that's 3 mg times x. That's going to be equal to the tensional force on the rope acting in the opposite direction, so T sine alpha times by 2a, the distance from the pivot point. I'm going to factorise mg out to the left-hand side, so mg lots of a plus 3x. We know that sine of alpha, we actually have another 3, 4, 5 triangle here, so sine of alpha will be 3/5. Then next step, I'm going to simplify the right hand side, so leave the mg, a plus 3x alone, and 3/5 times 2a is 6/5 a, lots of t, and then multiply both sides by 5, divide both sides by 6a, and we get 5 mg, lots of a plus 3x all over 6a, and that's our value of the tension, which is what the question wanted. For B, we're going to resolve horizontally. So forces going to the left, we've got the component of the tension in the horizontal direction, that's T cos alpha. The question tells us that the reaction force at the wall is 2 mg, so they'll be equal. Then we can substitute our expression for T from part A into this equation. So replacing T with the 5 mg, lots of a plus 3x all over 6a, we'll times that by cos of alpha, which is 4/5. That's going to be equal to 2 mg. Then simplifying that down, we can divide both sides by mg to cancel the mg's, put the 4/5 into the fraction, and we get 4 lots of a plus 3x over 6a. That's going to be equal to the 2 that's left on the right hand side. Bring the 6a over, or we can simplify the 4 over 6a first and bring the 3a over. And we're left with a plus 3x equals 3a. And therefore 3x equals 2a. X will be equal to 2 over 3 lots of a. Part C, we're going to resolve in the vertical direction. So forces acting upwards, we've got the component of the tension force acting upwards, that's T sine alpha, plus this normal reaction force at the point A, which I'm going to just call Y. That's going to be equal to the forces acting downwards, that's the weight of the plank and the weight of the block, mg and 3 mg. We can substitute in our value for t, our expression for t from part A again. Sine of alpha we know is 3/5. I'll leave the y alone for now and join together the mg plus 3 mg on the right hand side, so that's going to become 4 mg. Next, substituting our value for x, that's 2/3 a, into the fraction, we'll get a plus 3 lots of 2/3 a. It's going to be 3a. 3a will cancel with 6a. We'll cancel also with the 3/5. It all simplifies nicely down to 3 over 2 mg. Plus y will be equal to the 4 mg. So subtract 3 over 2 mg, we'll get y equals 2.5 mg. Then tan of beta will be equal to the vertical component divided by the horizontal component, 2.5 mg divided by 2 mg, which is 5 over 4. For part D, we'll set our expression for the tension, and we'll set it to be less than or equal to 5 mg, which is really nice because we can cancel loads of stuff. The 5 mg cancels straight away on the left and the right hand side. We can multiply both sides by 6a, subtract a from both sides, we'll get 3x is less than or equal to 5a. Divide both sides by 3, x is less than or equal to 5a over 3. It's quite a nice cancellation down there. Therefore, the block must be placed closer than 5a over 3 from the point A for the rope not to break. And there we go, that's question 9 done. Question 10. Question 10, we've got projectile motion. I'm going to start by laying out what we know. Our initial velocity u will be equal to u sine alpha. We're working in the vertical plane here, so u sine alpha for the vertical velocity. Displacement is 1 when it goes from 2 to 3. The final velocity will set as 0 and a will be minus g. We're going to use v squared equals u squared plus 2as. So 0 squared equals u sine alpha all squared plus 2 times negative g times 1. So that's minus 2g essentially at the right. So bring that onto the left-hand side. 2g equals u squared sine squared alpha. Squaring the u, squaring the sine alpha. And divide both sides by sine squared alpha. We'll get 2g over sine squared alpha equals u squared, which is what we wanted. Then for B, find the size of angle alpha. We're going to use s equals u2, so we're looking at the horizontal directions here. Set s to be 20, it's given in the question. U is now u cos alpha, so times by t. There is no acceleration in the horizontal direction with this simple model for projectile motion. So t will be equal to 20 divided by u cos alpha. Then going back to the vertical direction, s equals ut plus a half at squared, which tells us that it's 0.75 meters above, so the displacement from the start position is minus 1.25. So minus 1.25 equals u sine alpha lots of t plus a half negative g lots of t squared. Then we can substitute our value of t for 20 over u cos alpha that we got from the horizontal motion. So all I'm doing now is rewriting our equation, but instead of t, we've got 20 over u cos alpha. And instead of t squared, we've got 20 over u cos alpha all squared. Okay, so the challenge is to now solve this equation and see if we can find alpha. Okay, so the u sine alpha over u cos alpha, I'm going to turn into tan alpha. The u's will cancel. Sine alpha over cos alpha is tan alpha. We still got the 20 there. Subtract a half g, or g over 2, and square the 20 over u cos alpha is going to give us 400. I'm going to substitute u for 2g over sine squared alpha and times that by the cos squared alpha. That's there. Then I'll leave the negative 1.25 alone. I'll leave the 20 tan alpha alone, and we'll rearrange this fraction. So we've got minus g over 2. I'm going to bring the 2g over sine squared alpha. I'm going to flip that. I'm going to cancel the 2 with the 400, and we can see that the sine squared alpha over cos squared alpha are turned into tan squared alpha. There's some things that would cancel here, so the g's are going to cancel. We've got the 200 over 2. There are other ways of simplifying this one, but this ends up in a place that works. 200 over 2 is the 100, and then we've got the tan squared alpha. We now are dealing with a quadratic in terms of tan alpha, so I'm going to write it in descending powers of tan alpha. So 100 tan squared alpha minus 20 tan alpha minus 1.25 will be equal to 0. And so I'm going to plug that into the quadratic equations formula. So minus b plus or minus b squared minus 4ac all over 2a. We'll get two values for tan alpha out of this. The first one is 1/4, and the second one is negative 1 over 20. If I do inverse tan of negative 1 over 20, I will get a negative value for alpha. So I'm going to eliminate that one straight away. We can see from the picture we're looking at the positive value of alpha here. So inverse tan of 1/4, which is 14 degrees. Alpha is 14. Okay, with C, this model assumes that there's no air resistance. Simple models do like to ignore air resistance because it makes the math a lot harder. But of course, in real life, air resistance is a very, very real thing. So that's one of the limitations here. Then for D, we now have a value of alpha. So u squared equals 2g over sine squared alpha. I could square root both sides. U will be equal to the square root of 2g over sine squared alpha. Plugging my 14 degrees in will give me a value for u, and then we know that t is 20 over u cos alpha. So to calculate t, we can do 20 divided by the value we just got for u there. I'm going to call it u because I'm going to use an unrounded answer, times by cos of the 14 degrees. Plug that all in, and t comes out as 1.1 seconds. Well done if you managed to get that one. Right, bye.